A very good morning to you guys. Today we are going to look at algorithms. Okay, this is our topic for today. Now, the first question is, what is an algorithm? What is an algorithm? All right. Now, an algorithm is a sequence of steps, a sequence of steps designed to perform a task. Designed to perform a task. Okay, that is an algorithm. So we are saying we have so many tasks that we do in our day-to-day life. For example, you want to bake a cake. All the steps that you take from rolling the dough, putting some eggs, putting whatever is needed for you to prepare a cake, all those steps that you take is also known as an algorithm. Okay? So we are saying an algorithm may be constructed. An algorithm may be constructed to describe the operation, to describe the operation to describe the operation of a complete system, of a complete system or a particular part of it, or a particular part of it. So we are saying an algorithm can be constructed either to describe the operation of the complete system, that is the whole process. Let's say if in the process of baking a cake, we can describe an algorithm to perform the operation of baking the entire cake, that is the complete system, or a particular part of it. Or maybe we don't want to bake the whole cake, we just want a kusukapa process yokuti dora ready kuiswa mu oven. We can also describe an algorithm only up to that extent yokuti the dough is ready to be put in the oven. Okay, that's what we mean by that point. So like I told you that we carry out algorithms in everyday life. At times we don't even think about it. Let's say urikujega the viri remotokari, uda kubvisa viri kuti uise spare wheel. That process of actually removing a tire, it's an algorithm, because hautangi wabvisa tire usati wajega motokari. You get the point. So whatever steps that you follow, maybe uchatanga waisa mastones kumberi kwemavhiri kuti mota isafambe kana yakujegwa and stuff like that, all those, because you in algorithm, the thing is it has to be a sequence of steps. It doesn't matter kuti it's more like in algorithms the order matters. All right, because even ukaperform SMA steps are 10, for example, let's say 10 steps are required for you to solve a particular problem. So the thing is, if you perform uchitanga chero ya wada, you will not actually achieve whatever you want to achieve. Imagine ujega motikari, you do all the steps but you start with the wrong ones. Maybe unotanga sunungora manatsi ese utanga udunza viro sina ujega moto. I mean, it won't be possible. So it means pane zvinotanga pane zvinopedzisira. That's why I was emphasizing with it has to be a set of steps. All right. Now, let me give you another very good example of an algorithm, a day life algorithm. When you cross a road, comma, you perform a sequence of steps. You perform a sequence of steps designed to get you to the other side safely. To the other side safely. All right. So let me perform the algorithm. So the first step, or step 1, step 1, you stop before crossing. Stop before crossing. Okay. Then step 2, you look left and right. You look left and right. Okay. Step 3, is the road clear? Is the road clear? Okay. Then step 4, if not, stop. Okay. Then the last step, which is step 5, is clear, cross. Okay. So this is an algorithm for crossing a road. So like as you can see, you have to follow the steps, the first one at the first and the last one at the last. So if you start, let's say with step 3, or let's say if you start with step 5, it won't be possible, right? You don't just have to go and cross right away. You have to do the first steps. All right. So designing algorithms to solve computer problems is non-different. You still need to think about the sequence of steps required, because remember, algorithms were in computer science, so it's more like we will be needing to solve computer problems. Okay. So in the exam, you need to be able to create, interpret, and correct and refine algorithms using the following. So we use things like, number one, we have what is known as the flowchart. Number two, we have what is known as the pseudocode. And number three, we have what is known as the high-level language. High-level language. High-level language code. Okay? These are the three things that we use to describe our algorithms. So let me start with the flowchart. Okay? Now, what is a flowchart? I think that's the first thing. So, a flowchart is one method of representing the sequence of steps, in an algorithm in diagram form. Okay? So let me write an example of a flowchart. We have the start, we have the input number one, from keyboard. Input number one from keyboard. Then another one. Input number two from keyboard. Input number two from keyboard. Okay, then from there we have a diamond like shape is number one, creator. In fact, let me redraw. Is number one, greater than number this. And the output we open brackets, we put inverted commas and write the largest number is 1, the largest number is 1, and here we output the largest number is 2, close our bracket. Okay, then we stop here. This is where the flowchart ends. Okay, so what is happening here? This is where it starts. So we have this like trapezium shape where we input numbers from the keyboard. So we input number 1. We have another one, we input number 2 from the keyboard. Then this diamond-like shape is the one that makes the decision. So it checks if number 1 is greater than number 2. If number 1 is greater than number 2, then it will go to the left side where the output is saying the largest number is 1. If not, it will go to the right where the output says the largest number is 2. So, and then it stops. Okay, so this is how the flowchart works. All right, now we need to describe the shapes that are used in the flowchart. We have this shape, the oval shape. This is called the oval shape. The oval shape is used for terminating. So it's terminal. Okay. Then this shape that I was using, it is used for inputs or outputs. Okay, in flowchart. Then we have a rectangle shape. This is used for process or for processing. Okay. Then we have a line. The lines are used for control, showing you are going from this point to that point. Okay. Then this one is used for decision. So whenever you are writing flowcharts, please take note of these things. All right. Now we move to pseudocode. All right. Now, what is a pseudocode? A pseudocode is an alternative. Text-based method. Text-based method of representing a sequence of steps, of representing a sequence of steps in an algorithm. Okay, so this pseudocode can be thought of as a simplified programming code. It can be thought of as a simplified programming code. Okay, we have the prefix pseudo. Pseudo, it means false or not genuine. There's no whatever pseudo. So pseudocode, it's more like we are saying it's not a genuine code, or it's a false code, something like that. Okay, so writing pseudocode allows us to lay down the logic of a problem in an almost real-like code way, without worrying about the rules and the syntax of a particular language. So we are saying a pseudocode, we are saying we are writing the general structure or the general logic of a program without worrying about the syntax of a particular programming language. What are we saying? In VB, there's a syntax that you need to follow. You use dim A, dim what. In C, there's a syntax that you follow, which is different to the one that you follow in Java or in PHP. So we are saying the pseudocode is now the general idea or the general logic of the code without following a particular programming language, because each and every programming language in a syntax is different. In a print statement akasiyana nanonyora mune the next language. So we are not following all these. We are just writing the general logic of a program. Okay? So we need to look at an example of a pseudocode. Okay, so we need to write a program. We need to write a program or a pseudocode program to output the largest of the two numbers. The largest of the two numbers. Okay? So here is how we do it. Number 1 equals to input then number 2 equals to input so this means that we are inputting a number 1, the first number, and number 2 we are inputting the second number. if number 1 is greater than number 2, then print the largest number is the largest number is plus number plus number 1. Okay, else print the largest number is the largest number is plus number 2. We close our bracket. Then we write and if. Okay, so now let's go through the program. Number 1, input. Number 2, input. So input in a tuma open closing bracket ndo command yekuti ukubvumidzwa kuti inputa number 1 pa number 2 kunzi inputa number 2. So if number 1 is greater than number 2, you are telling the compiler to print, the printer statement rekuti the largest number is number 1. Number 1 yacho inenge yakunyorwa the actual value yaunenge wa inputa pamusoro apo. If that condition kana isiri satisfied, we are saying kana number 1 isiri greater than number 2, ndipo inoprinta the else statement. Else statement rikuti chi? Rikuti the largest number is. It's obvious kuti kana number 1 isiri greater than number 2, then number 2 ndo iri greater than number 1. That's why we print the largest number is, inobva enter, inobva display figure yacho ungoisa pa number 2 apo pongochi input ma values ako. Ainyora kuti it's number 2, inonyora figure yawaisa pa once enter number 2 apo. Then kuenda if kana chiti end if vari kuti tatanga tichinyora kuti if patatanga apo kuti if number 1 is greater than number 2, tinofanira kuzoenda that if statement, so tinobva tati end if. So this is an example of a pseudocode. Thank you very much for watching. I hope you have enjoyed this tutorial. If you have any questions, please don't hesitate to let me know at 0784 002 002. Goodbye.